Hi guys, this is Chapter 12, Lesson 3 on box plots. You're going to need to have your math book out and open to pages 879 through 882. You also need to remember to copy everything down, so every graph that I make, every number I write, every bubble I make, I need for you to duplicate it on your papers, and you need to use pencil only. I'm noticing a lot of you are starting to use pens again on your work, and I will not accept it if you've got your work done in anything other than pencil. All right, so two things that we're going to learn today is, first of all, we're going to be talking about box plots. Box plots are going to use median, upper and lower quartiles, and extreme values. Now, the good thing about this is that we actually already know how to do all this. We know how to find the median of a set of numbers. We know how to find the upper and lower quartiles. You guys, that's Quartile 1 and Quartile 3. And then we're going to be talking about extreme values, which is really easy because those are your low numbers and your high numbers. So you'll see it'll all start making sense and being put together. The other thing we're going to be talking about is box plots are going to show the distribution of data. Basically, it's going to show you a lot easier how your set of numbers are spread out when you're comparing them to each other, really. So go ahead and turn your books. On this one here at the very top, where it actually defines what a box plot is. A box plot, or a box and whisker plot, so they are called sometimes box and whisker plots, uses a number line to show the distribution of a data set by using the median, quartiles, and extreme values. Okay, so you guys, I want you to direct your attention to this part over here that I just drew a box around. So what a box plot does is going to use a number line. Here is our number line right over here. So you can see the number lines there. It's going to use our median values, so you can see where they did that. So you've got our median. It's going to use your quartiles, so here's Q1, Q3. Now your lower extreme and your upper extreme. The lower extreme is the smallest number in your data set. So think of lower extreme, your lowest number. Your upper extreme is going to be your highest number in your data set. So very, very basic. And of course, we've been working on outliers, and that's this guy way over here. And on a box and whisker plot or a box plot, an outlier will be shown by that little asterisk looking star that's there. Now, one thing that's important for you to notice also is that what box plots do is they separate our data into 4 parts. Now, remember we talked about like football games. Football games are broken up into quarters, so basically they take the entire game and they break it up into 4 parts. Think of a school year. We do the same thing within a school year. We break it up into 4 parts. For quarter 1, quarter 2, which is halfway through the year, quarter 3, and then of course quarter 4, which is at the end. So box plots do the same thing. So here's your median is where your middle is, right there where I just drew my blue line. And then you've got your Q1, that's where your end of first quarter is, and your Q3. So if you look at this area right here that I just circled, that's your first part, your second part, here's your third part, and there's your fourth part. That's how it breaks up your data into 4 parts. Now, I didn't say 4 equal parts, I just said it breaks your data up into 4 parts using your information and your numbers. So let's go ahead and look at example 1. So here it says, number 1, to draw a box plot of this car. Let me start that over. Draw a box plot of the car speed data. So over in this area right here that I'm putting a circle around, we have our speeds of cars. So we've got 25, 35, 27, 22, 34, 40, and so forth. So the first thing you have to do in step 1 is order your numbers. Now you guys, what we're going to be doing basically here is measures of variation. We've been doing this. You're going to have to put your numbers in order. You're going to find your median. You're going to find your Q1 and your Q3, and then you're going to find, and you can actually stop there. We don't have to go as far as IQR yet for this part. So they've done this for us. You just don't see it, but they put their numbers in order. Now, when they did all this data, they found that the median, so now I want you guys to direct your attention over in this part right over here where I just put a red box around. They found that the median was 25. They found the Q1 to be 22. They found the Q3 to be 34. Now the lower extreme, I talked about this a moment ago, the lower extreme, so I'm now looking at this box right here, that's your smallest number. So if you guys go back and look at your data set, the smallest number that you have there is 19. So that is why that's considered our lower extreme. Now, the opposite is for upper extreme. The upper extreme is our largest number. So if you go back and look at your data set, the biggest number we have is 40, which is why that becomes our 40 there. Okay. So once you have found your median, your Q1, your Q3, and you know your smallest number and your biggest number, this is where we're actually going to start plotting these points. So this is what I'm going to have you guys do. So down at the bottom in your books, I know this is already done for you, but I want you guys to watch to see like how we would go about doing this. So the first thing you want to do is you're going to put a dot where your median would be on this number line. Now you're going to put it just above that number line. So I'm going to do the best that I can here using a stylus, but we'll see how well it goes. So I'm going to go ahead and start with my dot at the 25. All right, so you can see I've got my dot there. And then what I like to do is now that I've got my dot there, I'm going to draw a thin line that goes through my dot like that. So now I'm going to go ahead and put a dot at my Q1. Now my quartile 1 was 22. So I'm going to find where 22 is. So I'm going to put a dot at the 22. And then I'm going to put a line through it as well. And then I'm going to do the same thing with Q3. So I'm going to put a dot at the 34. And put a line through that one as well. Now what I'm going to do is I'm going to box these things in, okay? So I'm going to take my Q1, which was 22, and I'm going to go through my median and do this just like this as best as we can, okay? Let me put my dot back in there. All right. So that's what you're going to do with that one. So basically, you're creating a box for your, you're creating a box around your quartiles. Your median is going to be that line that's in the middle of your box. Now, it's not always going to be smack dab in the middle of the box. And you can see here that this is our median right there. It's not in the middle of our box, and it doesn't have to be, and it's not always going to be. What you're going to do next is now you're going to put a dot where your lower extreme number is and your upper extreme number. Now, if you remember, our lower extreme number was 19. So we're going to put a dot at the 19, just like I did here. And then we're going to connect it to our line like this, to our box. And then our upper extreme number was 40. So I'm going to put a dot at my 40, and I'm going to connect it to my box. Now, these guys right here, these are called whiskers. So where my blue arrows are, those are called whiskers. That's why this type of graph used to be called a box and whisker plot, because you've got the box and then you've got the whiskers. So now they just call it a box plot, but I'm used to calling them box and whisker plots. So sometimes you might hear me say box and whisker, but I'll try my best to go ahead and use it with the new terminology of calling it a box plot. But that's all that you basically are going to be doing. Now, there's no outliers in this data set, so we don't have to worry about using that little star like you noticed in the example on the top part of the same page that you're at. All right, so now it's going to be your turn. Now, I want you to look at example A. I want you to start by putting your numbers in order from least to greatest. Don't worry about the dollar signs. So just go ahead and leave out the dollar signs, but you do need to put your numbers in order from least to greatest. So what you're going to do here is once you put them in order, you're going to find the median, the Q1, the Q3, the lower extreme, and then the upper extreme. And then I want you, and if you need to rewind the video by a couple of minutes, go back and try to put them on your number line below. Now, your number line below does not have any numbers on it, so you're going to have to fill in your numbers on this, but I'll help you get started with it. What I would suggest that you do is start it at the number 15 and then just go up as high as you can. So for instance here, if we make this guy 15, this guy will be 20, this guy is 25, this guy is 30, and if we need anything higher than 30, and I'm checking, it doesn't look like we do, all our data should fit on this number line with these numbers here. Okay, so remember, what you're going to do is you're going to put your numbers in order, you're going to find the median, you're going to find the Q1, the Q3, and then you're going to put your dots with a line through it, and then connect your boxes. So all these three things, this is what's going to be within your box, and then your lower extreme and your upper extreme become your whiskers. Okay, so you guys go ahead and pause your video now and give this a shot. All right, so putting our numbers in order, here's what we're going to get. So the next thing I'm going to do now that I have my numbers in order from least to greatest is find my median. So as I'm crossing these out, I find that my median is 20. So now what I'm going to do is put a box around my lower part, which is right over there, and now the upper part. Now notice and remember, I did not include my median of 20 inside either of those boxes. So the next thing I have to do is find my quartile 1, which is the median of my lower end. And that ends up being 17. And now I have to find the quartile 3, which is the median of the upper box, and that ends up being 27. So now I'm going to go down to my graph. So on my number line, actually, I should say, I'm going to put a dot at the 20 for my median, and then draw a line through it. I'm going to put a dot at the 17 and a line through it. That's my Q1, and then I'm going to do the same thing with 27, which happens to be my Q3. Now I'm going to draw a box around those. So the number that's in the middle, or the line that's in the middle, so I'm looking at this guy right over here, that's my median. So it's going to be somewhere inside my box, not in the center of the box always, but it's going to be somewhere inside my box. So now I'm going to put in my lower extreme. The smallest number in my data set is 15. So I'm going to put a 15 or a dot at the 15 and then connect it to my box. And now I'm going to put a dot at the 30, which is my upper extreme. That's my biggest number. And I'm going to put a dot there and connect it to my box as well. So now what we've done is we've created a box and whisker plot. One thing I want you guys to notice here is what this does is it shows you on a number line where your numbers are broken apart. So over here, you'll notice from this part right here that I'm circling in yellow, and I'm not sure if you can see this on your screen, but I went ahead and circled the line that goes from the 15 to the first part of my box. So the first part of my box obviously is at the 17. So if you look at your number line, we're looking at between 15 and 17. What that's telling us right there is that 25% of my data is going to fall right in between the 15 and the 17. So you can tell that those numbers are going to be kind of squished together over in that area here. So they're going to be squished together in this area. I have the same, so that's 25% of my data. The other 25% is going to be over in this area right here. So you can see that you've got a little bit more space. That goes between the numbers 17 and 20. And then my biggest area is this part right here. Oh, that's pretty bad. There we go. This is another 25% of my data. So my numbers there are more spread out in that area. And then, of course, lastly, this part right here where I've got some numbers spread over in that area. So, and I had mentioned 25%. You know that if that's 25% and that's 25%, and this area is 25%, and so is that, it's going to equal 100%, which means the total amount. All right, so for this next part, I went ahead and on the screen, I put the box plot that we came up with for car speeds on our previous page, and we're going to look at the next two examples. Now, a box plot does not show individual data, so you can't really see like what your data set is once you've made your box plot. However, it's really good to use for you to interpret your data. So one thing I want you guys to notice here, and I'm looking inside my box plot here, and I'm going to highlight this with a red marker for you to see the part that I'm talking about here. This box right here that I just put a highlight, or that I just outlined for you in red, this is where 50% of our data is. That's half of our data. It's our inside part. This is the part that's between our quartile 1 and our quartile 3. I'm going to take this part away. I want you to notice my median, which is right here. My median is always going to be the line that's inside the box. Now, the median tells me where the middle set of my data is. So if you remember, you guys, when you're finding the median of a set of numbers, it's the number that's smack dab in the middle. So that also means that you have the same number of numbers on this side, and you have the same number of numbers on this side. So look at this median right here. So you see where the median is, but look how short this arrow is, and look how much longer that arrow is. And that's basically telling you that you have half of your numbers are more spread out on the right side, whereas on the left side, they're a little bit more closer together. So if I were to take my class and split them up in half, so you each had, so let's say we have a class of 22 students, and I have 11 of you stand on one side of the room and 11 of you stand on the other side of the room. Well, on the left side of the room, maybe I'm going to squish you 11 people between between 6 spots, because that's how many numbers are between 19 and 25. So maybe I'm going to have you stand, all 11 of you, in 6 little spots, whereas the other half of the room can sit there and spread out among 15 spots. You're going to realize that, this side of the room has much more space because they get to be spread more out, even though it's the same number of students on each side of the room. So maybe that kind of helps you there. So look at example 2. It says, refer to the box plot in example 1. This is what I put on the top of your screen. It says half of the drivers were driving faster than what speed? Now you guys remember, our median is our middle number. So if half the drivers were driving faster than what speed, it would be faster than 25 miles an hour, because half of my middle half guy of my driver is at 25 miles an hour. The rest are more than that. Look at number 3, or example 3. It says, what does the box plot's length tell about the data? Now, I kind of mentioned this before. The length of the left side is short. So if you notice, if you notice this part right here, and I need to move this down, there we go. This part's a lot shorter than this guy right here. So the left side of the box plot is short, and that means that the speeds of the slowest half of the cars are concentrated. It means that those numbers are closer together. When something's concentrated, it means it's not as spread out. It's more condensed. It's just squishier, not squishier, but squished together, closer together. Whereas the right side, since we've got all this extra room, it means that our data is much more spread out. All right, so look at the bottom of your page. This is example 4. The box plot below shows the daily attendance at a fitness club. Find the median and the measures of variability, then describe the data. Okay, you guys, so we've talked about measures of center and we've talked about measures of variability. Measures of variability have to do with the median, Q1, Q3, IQR, and the range. So over on the side of your book, or on the bottom where you have room, I need for you to write measures of variability and list what they are. Those 5 things you have to find for measures of variability. So pause your video now if you need to. Okay, so we should be able to look at a box plot and get an idea of what these measures of variability is. Now the median is going to be the line that's inside your rectangle box. So if you look here, this is the only bad part about box plots. If you look over here that I've just circled, we have our median right there. So if you look down to see about where the median is going to be, it's going to be somewhere between 70 and 75, like right in the middle. So the book is estimating it to be at 72.5. Now notice how they wrote this. They wrote this in a sentence. So they said the median is 72.5. So that is a great sentence. You're going to start there. Your first quartile. Now, if you remember when we create our box plots, our first quartile is where our box starts. That's right there. Well, look straight down. You're at the 65. So then it tells you that the first quartile is 65, and then it's going to go on to the third quartile, which is 80. And remember, where our box ends is our third quartile. So you can see that that's how they got the 80 there. The range is 54. Now, let me remind you where they got the range from. The range is your largest number minus your smallest number. Now, the largest number on this one happens to be 110. Now, you'll notice right over here, you see that little asterisk star there? That's our outlier. It's still our largest number. Our smallest number, I would probably say, is about 56-ish. So we're going to go with 56. When you subtract these two numbers together, this is where we get our 54 that the book says that we have a range of 54. Now the IQR is your interquartile range. Remember, you're going to take your 80 minus your 65, and that's how they got the 15. So you can see so far here, you guys, this is everything that you would normally be putting in list format, like the median is this, Q1 is this, Q3 is this, but just pay attention to how they basically just attach words to it and put it in sentence format, because this is the type of stuff that I need to start seeing that you guys are going to be doing and talking about. Since this is an outlier, you have to tell me there's an outlier. So there is an outlier of 110. We know that because we've already addressed the fact that you have that little star there at the end. Then it says both whiskers are approximately the same size, so the data without the outlier is spread evenly below and above the quartiles. Okay, so let me clean off some of my mess here. Oh, I didn't mean to do that part. Hang on a second. And let me do this. All right, let me clean this part off here. So it's talking about the whiskers. Remember, we talked about this is a whisker and this is a whisker, okay? So if you notice here, think of like whiskers on a cat. If you notice there, the whiskers, even though this one's a little bit longer, the whiskers are about the same size. And what that means is that our data, our information is spread out kind of evenly, like on this side and evenly on this side. Even though this side to the right is a little bit longer, you can tell that it's much more, it's more symmetric. It's kind of like more even. And you'll notice sometimes, because you'll get box plots that might look like this, where you're going to get a whisker like that and a little itty bitty one like that. So you can see that obviously the whiskers are not the same size on that one. Okay. So that's it for now. I'm not going to have you guys do the guided practice because we're going to practice making box plots in class when you guys return to class tomorrow. But make sure that you've taken all the notes that you need to take so you can refer back to them when it's time for you to create some of your own stuff. All right, guys, have a good evening.